All right, here's our final video from section 4.1. We're going to finish off example 5 and 6 and then have you try some problems before we move on, okay? We've been talking about exponents and the different rules for exponents. Let's add to that right now and talk about what happens when we raise a product to a power. That means if I have a bunch of different things inside being multiplied and then I also raise it to a power, what do I do? Or what happens if I'm dividing and I raise it to a power? Well, really, all we're kind of doing here is just distributing. So if I have a couple of different pieces inside and I want to square it, what that really means is I want to square the 3 and I want to square the x and I want to square the y cubed. So you're really just kind of distributing that exponent throughout. Now remember, when we raise a power to another power, what do we really do with those exponents? We multiply, right? All right, same idea if we have a division problem. If we have a whole bunch of terms in the top, a whole bunch of pieces on the bottom, and we are raising it to an exponent, we're really just making sure that we're distributing that exponent to everything in the numerator and distributing it to every base in the denominator. Let me show you some examples. Example number 5 here has a 4a cubed. I don't have any plus or minus signs. There's one piece inside, one term, right? And I want to take that 3 and I want to distribute it to everything in that parenthesis. That means I want to take that cubed and I want to make sure that I cube the 4, and I also want to make sure that I cube the a. Or another way of thinking about this is cubed means I have 3 of these multiplied together, don't I? I have 4a times another 4a times another 4a. Or how many 4s do I have? I have 3 of them. And how many a's do I have? Well, I have 3 of them. And so I can think of it either way. Okay, I'm kind of distributing that exponent throughout though. I can simplify a little bit and figure out what 4 times 4 times 4 is, and I end up getting a final simplified answer of 64a cubed, making sure that you distribute that 3 to every base in that parenthesis. Let's look at B. B has this quantity squared. That means I want to make sure that I square every base in this parenthesis. So really, I have a -5 that I want to square, and I have a x to the 4th that I want to square, making sure that I square every single piece here. Now remember that -5 was in parentheses, so I want to make sure that I take that -5 and square them. That means I have a -5 times another negative, and remember that 2 negatives make a positive, so I should end up with a positive 25. And then remember here, when we're raising to a power, if I have x to the 4th and I want to square it, I really just multiply the exponent. So my final answer should be positive 25x to the 8th. All right, look at C. C is a little bit different. We got a couple of things going on here. Don't we have a quantity that's raised to the 2nd power times another quantity? And so if you remember your order of operations, we should be doing exponents before we multiply. So we really need to make sure that we square this first piece before we multiply it with that second piece, okay? And so using our rule, we should be able to take that squared and distribute it through to each base. And remember, when I raise a power to another power, I really multiply. So I'm doing 7 times 2. That's where I got the a to the 14th. I'm doing a b to the 1st, right? Raised to the 2nd power, so I'm really going to multiply their exponents, and I got b squared. Now don't forget, we have this second piece here in the back, and because it was right next to the other piece, I know I'm multiplying. So now I can say that I have a to the 14th, b squared, times an a cubed, b to the 4th. Remember, I'm only distributing the 2 to the parentheses in front of it. And so the a cubed b to the 4th is just an a cubed b to the 4th. We're not squaring that piece. But now that I have like bases, I should be able to combine some of my like bases. I should be able to take this a to the 4th and multiply it to the a to the 3rd power, right? A cubed. Now remember, we've got to switch our brain a little bit now. When we're multiplying, what do we really do with the exponents? Oh, don't we add now? And so I'm going to combine my like bases by adding their exponents, and I end up getting a to the 17th times b to the 6th. Because those are different bases, that would just be my final answer. Remember to follow your order of operations so you get the right answer. All right, now I need you to be really careful. I'm going to caution you here. We haven't done a problem like this yet, but keep an eye out. Do you see how this has 2 different pieces with a plus or minus sign connecting them? We call this a binomial. We'll talk about that later in the chapter. But if I have a plus or minus sign separating my terms, you cannot distribute this 2 through like we were doing up above and say 5 squared plus x squared. Unfortunately, it doesn't work the same way. The only reason we were able to do it in these last few problems is because that each of these pieces was just one term, we call it. There was no plus or minus sign separating any of the pieces. It was just one big chunk that we were distributing the exponent to. If there is ever a plus or minus sign in between, we cannot just distribute that 2 through. We'll talk about what to do in later sections in this chapter. So just be careful. Don't do that if there's a plus or minus sign separating your terms. All right, we did some ones just up above about multiplication. Let's look at some division ones. So if I have an x over 5, x divided by 5, and I want to square that quantity, what I really have is I want to distribute that squared to everything in the numerator and everything in the denominator. So I really have an x squared over a 5 squared. Or I can simplify it and say I really have an x squared over 25. All right, do the same thing with part B. I have 5 over a to the 4th, and I want to cube it. That means I want to cube the 5, and that means I want to cube the a to the 4th. 5 cubed, that's 5 times 5 times 5. You end up getting 125. And then when I raise to a power, I'm going to multiply the exponents, and I got a to the 12th. All right, let's look at C. Now be careful. How many bases, how many things do you have to distribute that squared through? You should have 3. You should be distributing it. You should be squaring the 3 and squaring the a to the 4th and squaring the b cubed. A common mistake on this type of problem is students forget about this 3. They just leave him a 3 instead of making sure that you square him as well. So he's a base in its own. And so we need to make sure that we square the 3 and we square the a to the 4th. That's a to the 8th. And we square the b cubed. That's really a b to the 6th. And so my final answer simplified would be 9, that's 3 times 3, a to the 8th over b to the 6th. All right, now that we've talked about all those different exponent rules, I would like you to take a few minutes and try these. So pause your video, try these problems, and then see if you get the same answer as I do. It's really, really, really important that you're trying these, practicing on your own to see if you really are understanding the concepts. And if not, please reach out to me if you have any questions, okay? All right, on this try at number 1, I have q minus 5 to the 7th and q minus 5 to the 3rd. They're both q minus 5s, the same base, so I should be able to combine those. It looks like here I am multiplying, so when I multiply, I really add their exponents, so you should end up with a q minus 5 to the 10th power. Now be careful, don't distribute that 10th power because there's a plus or minus sign separating your terms, so that would just be your final answer. All right, look at number 2. It looks like on number 2 we're dividing. Remember, when we divide, we really subtract the exponents as long as our bases are the same. And it looks like our base is the same. They're both 4s. I have 4 to the 13th divided by 4 to the 10th. So how many 4s do I really have left over? My base stays the same, and I subtract their exponent. You should have 4 cubed, not 1 cubed. Be careful not to cancel out those 4s. You have 4 to the 3rd power left, or 64. That's 4 times 4 times 4. I hope you got it. All right, look at number 3. Number 3 has a big old chunk. We call it a monomial. It's one term. And we're going to make sure that we cube every single base in that term. So we're going to cube the negative 2. We're going to cube the x cubed, and we're going to cube the y squared. You should end up getting negative 2 cubed as negative 8, x to the 9th, and y to the 6th. Because when we raise to a power, remember, we really multiply the exponents. All right, this last one has a couple different pieces here. You should hopefully have distributed and raised everything to the 3rd power first before combining it, multiplying it by this last piece. When you raise to a power, remember, multiply your exponent, so you should get a to the 12th times b to the 6th. I have my second piece here, that's just an a squared b to the 5th, but now I want to combine them by multiplying. Remember, when we multiply, we really add the exponents. So you should end up getting an a to the 14th and b to the 11th. Those are not like bases, so we can't do anything more with that. That would just be our final answer. Make sure that you continue practicing all of these different rules. If the silly saying helps you, use it. All night my aunt ran mail downstairs. When I add and subtract, I do nothing with the exponents. When I multiply, I add the exponents. When I raise to a power, I multiply. And when I divide, I subtract their exponents. Make sure you know all those different exponent rules. We'll be using it a ton in this class and lots of other math classes in the future. So make sure you're comfortable with that. Let me know if you guys have any questions or need anything.